Hello, friends. Uh, Wanted to share a few things with you right quick about computer architecture. I had a couple announcements to go over and added a new quiz. And I also have a quick solution set for the homework. So I wanted to share all that with you today. Let's go ahead and share my screen. That way you can see what I'm looking at and we can go ahead and get started. Okay, so here's an email that should have got broadcast to you today, and I'll read it to you. Classes are now virtual. There are some reasons why they call it virtual and not online, and so that's why I'm telling you this is a virtual class. Unique opportunities, fun way of saying this could get interesting. There are some things that are going to go sideways and things that are going to be more difficult and some things that are just going to be flat annoying. But this is the situation, the world around, and so we're going to make the best of it. And so how we perform in these tasks are going to be the things that we can put on resumes later. All right, so asynchronous. There was a debate. Should we have Zoom meetings? Should we have Discord meetings? Should we do Google Hangouts? And I really felt what would work the best given all of our different work schedules, all of our different living schedules, some people getting kicked, moved out of the dorms and stuff like that. I figured let's just go to an asynchronous model where I'll present material and then when you get the chance, you'll consume it. And then also whenever you have ability to do work, to watch videos, stuff like that, go ahead and do that. And then you can email me questions, hit me on Discord with questions, Canvas message me with questions. But one of the key things I want you to understand is you are an important part of this class. There have been times this semester before when I will be making a Zoom recording and I will be showing you things on the two monitors that are right in front of me and I can see it just fine and I will forget to go and turn on the monitor behind me. These things happen. When these things do happen, I need you to provide me feedback and let me know, hey, fix this. And that's the only way. I will do my best to try to filter for that stuff, but that is one of the best ways to make sure you're getting what you need to be successful. Okay, because you are important to me, I am not going to just be like, oh, hey, forget attendance. No, you matter to me. And so that's why I want to do this. And that's why I'm not asking things like, oh, is this a reading quiz or something like that? Did you watch my video? Did you catch the fun thing that I did with my hand or something like that? No, that's stupid. These are things that I want to know that I am interested in. And I know these change from week to week. And so that's why I'm going to ask you these questions. Are you safe? Do you have enough to eat? What are you doing to take care of your health? I will admit that's the one I kind of expect you to put the most effort into. I want to know, what are you doing to take care of my students to keep them healthy, keep them running well? And I don't just mean like physical health, like Jason Yeager. If you're, I don't want you to necessarily talk about, and I went to the gym and I did 4 sets of 10 on lat pull downs and things like that. No, what I'm talking about is, mental health, physical health, emotional health, spiritual health, financial health. All those different things matter. The things that you're struggling with or the things that you're proud of, go ahead and share those things there. And if you were like, hey, I'm really proud of this, I want you to share this with other people because I think this is a great idea, go ahead and let me know that. Okay, and then finally, do you have what you need to be successful in your education? All right, stupid stuff. I kid you not, I about lost my stuff this morning because I had a USB type A2 or something USB adapter that I needed for a desktop scanner. I needed to scan in a document. It took me 45 minutes to find that thing, but I did eventually find one. If you run into a situation where you're like, I cannot live without some, thing A or thing B, we'll put our heads together. We can try to come up with a solution together. I can put you in contact with other people that you can get a hold of. I'm going to try to lean on Canvas again, continue to lean on Canvas. We've got the quizzes already loaded in Canvas for this week. I'm flexible on the quizzes. If you've got some other ideas for questions we could ask next week, I'm cool with that. The quizzes are due on Friday. I leave them open until Sunday, and then on next week I'll load up new quizzes in Canvas. But the idea there, this is like a wellness check, and I just want you checking in. I want you to confirm with me, hey, we're fine, we've got a plan. I gave you till Friday because like I got an email from one of my students, they're on an airplane traveling to their home country or something like that. Understand, I'm proud of all of you. I want to do my best to help. I am staying home. I've seen a lot of the news, people talking about that, doctors on, Oklahoma doctors online talking about what we can do to help. I am doing my best to stay at home. And so I think together, we're gonna make the most of this. I've seen Dr. South out on Facebook, sharing a lot of good stories, a lot of good faculty out there trying to make a difference. This is my cell phone number. If y'all need to send me a text, go ahead and send me a text. Okay, so looking at the schedule, we're supposed to be, there's a couple more announcements I wanted to go over right quick. The Discord server, just in case Canvas gets owned, we've got a backup. Just in case campus email gets owned, we've got a backup. Just in case my text messaging falls down, we've got a backup. So the point is, this is one more way for you to reach out into the world and get help, possibly from me, possibly from other people, but this is one good thing. All right, another thing that I'm excited about, I've set up a YouTube channel called Programming Better with Jeremy, and I've been having some fun with that. But it's the SWOSU Computer Science YouTube channel. And so y'all are welcome to make content if you want to start adding stuff, if you want to stream or something like that, go ahead. Let me know that. I can add you as an administrator. And after we get done adding you as an administrator, you can get your own playlist or things like that. But I thought this would be kind of a fun way that we could come together and kind of share our learning experiences and things like that. So this is what the quiz looks like. It's a text entry box, and the general idea is I just want to make sure that you're being taken care of. Okay, so let's see, I can drag this over here. There we got it. Okay, so last week was spring break. This week we're getting into the processor architecture and the instruction set and logic design and hardware control language. This is fun stuff for me, especially logic design. I had a lot of fun working on this problem set. Here's the 5 problems. Basically, we start at 4.8 and go to 4.12, so 5 problems. And like I said, I had a lot of fun with them. Modules. Let's just do a new module, and I'll call this class documents, add a module, and then we'll have a file, a new file, choose the file. I've got a little folder here called scans that I've got this loaded in. And so there you have what you need. I do want to point out sometimes the internet has been slow. And so, but anyway, if you go to the computer architecture Canvas page, go down to modules, then we'll have a class documents, and you can click on this PDF here. All right, so let's go ahead and walk through this. Like I said, 8, 9, 10, 11, and 12. By the way, this is the document that I couldn't find the cable for. And so I found the cable, and I'm much happier little human being now. Problem 8, the following assembly code lets us determine the behavior of the instruction set. Okay, this made me realize I need to go back and reread chapter 3 and try to get my head wrapped around those and work several more of those practice problems, because the Y86 instruction set is supposed to be a little bit of a reduced instruction set, and this stuff was not clicking for me yet. So basically what I did is it says, we find this function always returns 0xabcd. What does this imply about the behavior of popq %r from the register RSP? What other y86 instruction would have the same behavior? Okay, so the code sequence, this is straight out of the back of the book. It pushes this value onto the stack and then pops it to this register and returns that popped value. Result is equal to this. We can deduce that it sets the stack pointer to the value read from the memory. This is equivalent to a memory read from the RSP to the RSP. All right. So anyway, I need to go play with that some more. That's starting to click, but I definitely took a break from spring break and my brain didn't jump back to that. Now, getting into section 4.2, this is more in my wheelhouse. I've got very fond memories of spending days upon days studying this stuff in the basement of a engineering south. And so it says, write an HCL expression for a signal XOR equal to the exclusive OR inputs of A and B, and what's the relation between the signals for XOR and equal defined above. Okay, so here's XOR and here's equal. If A and B are both 0 or both 1, this puts out a 1, otherwise it puts out a 0. And if A and B are only one of the two is true, then an exclusive OR is true. And so here's the code, the answer they give in the back of the book. This is how I think about it inside my head. And I just drew a little schematic to show what this looks like. This is an AND gate, this is an AND gate, this is an OR gate. Here's the result. And we've got these two are inverters. And so this is the schematic of an exclusive OR. So in general, equals and exclusive OR are complements of each other. Okay, so that's what this truth table shows. If the exclusive OR is 1, then equals is going to be 0. And if it equals is 1, exclusive OR is going to be 0. Cool, moving on. 4.10. All right, suppose you want to implement a world level equality circuit using exclusive OR. Okay, so this is basically saying, hey, you remember that thing you just got doing? All right, how do you scale it up to something big enough that we can actually do something with that? Design such a circuit for a word consisting of 64-bit level exclusive OR circuits and 2 additional logic circuits. Do you have to use 2 additional logic circuits? No, you don't. And they kind of get into that in the explanation down here. They say the output of the exclusive OR circuits is the complements of the bitwise, and using De Morgan's law, we can implement AND using OR and NOT. So what we could have done, this chunk right here, we could have been like, hey, let's just do an AND gate. And let me read that to you and make that make sense. The exclusive OR is a true false. And so what this is putting out is exclusive OR. If you wanted to get to, all right, so this little dot right here would have been your exclusive OR output. If you invert your exclusive OR, you get the equals output. So, all right, we could have just had an AND gate instead of an OR gate and a NOT gate. So, all right, moving on. Here we have the HCL code given for computing the minimum of 3 words contains a comparison. Rewrite the code that computes the same result, but only using 3 comparisons. So here's what they have in the back of the book. They say, listen, we're only going to grab the first one that can be done. And this is because since the first will detect where A is the minimum, the second line need only determine if whether B or C is the minimum. So if B is the minimum, if B is less than C, then choose B, but otherwise it's going to default to C. And that did not make sense to me, so I just wrote this out to make it a little more sense to me. The minimum of the 3, so like I said, this one is going to say, hey, is A less than B? If that's true, is A less than C? Okay, if both of these conditions are true, select A. Otherwise, keep going. Okay, so this one takes care of, for sure it was A, but if it's not for sure A, then it's going to be B or C. So this line says, okay, is it B? If it is, choose B. If it's not, then just do the default behavior, which is choose C. And then we close the program. All right, last one. Here we go. It says, write an HCL code describing a circuit for word inputs A, B, and C. Selects median of the three values. That is, the output is the one. We don't want the minimum this time. The code we wrote last time was choose the minimum. We don't want the maximum. That would be just kind of the inverse of what we did. It says, pick the one in the middle. And so this was the old code that they had. This one they didn't like because it had 4 comparisons and 2 AND gates. So they had us rewrite this one, and they're like, hey, you can actually cheat and not do this. Yeah, I get that, and I could probably put some thought into it, but I like this as a good starting point because this makes sense. You can take A less than B and A less than C, and that chooses A. Well, if A is the median one, this would say, okay, B is the minimum, C is the maximum. If we switch that, so if we said C is less than or equal to A, so basically let's see if I can grab just this. There we go. So if we switch the order of these two, and we said A less than or equal to B and C less than or equal to A, then choose A. That's basically saying, okay, C is less than A, B, C is less than A, B, this is why I write these things down. Let's just go ahead and see what this looks like. Okay, so this is the case where B is the max. So A is less than or equal to B, and C is less than or equal to A. So B is the maximum and C is the minimum. In that case, choose A. We could also have the case where B is the minimum, so B is less than A and A is less than C, in which case also choose A. And so this is just kind of an expansion of that first line, or this is what I was talking about, A less than or equal to B and C less than or equal to A, choose A. So that's what I was trying to explain. It makes more sense when you write it down. So there it is written down. And then I basically said, okay, let's shuffle this just a little bit. Let's say B is less than A and C is less than B. Okay, choose B. B less than C, A less than B, choose B. And I kind of use these little comments here at the end to kind of let people know what's going on. And then the default behavior, 1, if it's not A in the middle, it's not B in the middle, it's C in the middle. You only have 3 choices. Those are your choices. So just for funsies, I said, hey, what would happen if we dropped OR gates in the middle? I went back and I used the solution they gave in the back of the book and just kind of reorganized it. So in hindsight, I would have done this where A was my first selection, B was my second, C was my third. Hey, you know what? Life, it goes on. So anyway, that's my set of solutions for the 3 homework problems for this week. Everything in this class is asynchronous. I'm going to try to make this material and make it available to you. And when it is available, I'll send you a notification in Canvas. Just to kind of take the weight off of Canvas, I'm going to try to upload my videos to YouTube. That way you can go out and use the YouTube servers to download the videos and watch them there. If you have any questions, if there's anything I can do to help, go ahead and let me know. We've got a bunch of good tools that we can use. Email is working. I like email. I also am familiar with Discord. I don't get back to Discord as quick as some other people in the Help Me channel might, but I do eventually get back to Discord. I've got notifications on my phone, so that is a viable option. I've also got the Canvas messages on my phone, but email is the one I probably go to and work most diligently out of. If there's anything I can do to help, let me know. If you guys run into any problems, let me know. We're going to get through this. This is going to be awesome. We're going to have some fun. We're going to learn some things, and hopefully you all have a good time and you continue education. Thank you for being here. Thanks for spending time with me. I hope you all stay safe out there. Take care.